As promised, this is a sort of finale lecture that tries to sum up at a high level what we did this quarter in natural language processing. Um, so back at the beginning of the class, I showed you an outline of what we were going to cover, and we stuck pretty close to that. We spent a few weeks talking about probabilistic language models, and I used language models as a way to introduce the key machine learning ideas that we need for this class. Namely relative frequency-based estimation or maximum likelihood using count-based models, then log linear models based on handmade features, and then neural networks based on automatically learned features. We then looked at an application area, text classification, which I argue is the most commonly used NLP type application in industry today. And so we talked about how to think about text classification and methods that we might use, and some of the use cases for that abstraction. We spent a little time talking generically about word representations and sort of the old versions and the newer versions, leading all the way up to recent development, Elmo, which is based on contextualizing each word and representing each word token with its own vector rather than a type. Then we got into the sort of structured part of NLP. We spent about a week, maybe a little more, on sequence models. We talked about hidden Markov models and dynamic programming, and talked about how these can be generalized with feature-based and neural methods. Then we turned to even more powerful representations of the syntax of natural language, and spent a few lectures talking about parsing algorithms and techniques, and sort of where the data comes from, tree banks, and so forth, and some of the challenges. We spent about a week on bytext and machine translation, a very active application area today, and some of the methods that were introduced there that have then been ported to other areas of NLP. And finally, we closed with semantics and talked about a few different views of semantics beyond word level. Lexical semantics, which was covered earlier. We talked about semantic roles, predicate argument structure, and then finally in the lecture on Monday, we covered logical semantics, compositional semantics, how you map from natural language expressions into, for starters, first order logic. All of these topics we could have covered at much greater length. There's a whole lot more to be said. I tried to pick some sort of nice examples of techniques and algorithms and abstractions that are widely known, but this is only a one-quarter class, and there's a whole lot more we could have covered. Here are just a few more things that if we'd had time, we might have talked about, and this isn't exhaustive. These were just the things I thought about this morning on my way to work. One big area that's getting a lot of attention and press lately is conversational NLP, and I really said nothing about how to build dialogue systems or systems that interact with people. There's a course on this in EE being offered in the spring. I believe it's called 596D this time. Last year it was 596 something else, but there's a web page on the slide that you can use if you want to check this out, and maybe register for that class if you want to know more. It should be a more hands-on and applications-oriented offering. And there are a ton of application areas we could have spent a lot more time on. We could have talked about information extraction, question answering. These are both big areas that get a lot of publications each year. Information extraction is essentially trying to take text and turn it into more structured representations that are easier to work with. So transform large bodies of text into something that's more grabbable by other kinds of programs. Building knowledge bases, for example, we talked about a little bit last lecture. Question answering, of course, is natural language questions in and answers come out. One very popular line of work from Stanford is called SQuAD. It's a data set that lets you train a model to find an answer to a question in a passage. That used to be, it's very similar to a class project I used to use in this class when I taught it in a semester system and had 15 weeks. I actually had, if you had taken that class with me then, you would have gotten to build hands-on a question answering system and a question generation system to try to stump the other students' teams. Other active areas where people are applying NLP: language and vision, for example, answering questions about images, language and robotics. We want robots to understand us and do what we tell them, so figuring out how to translate between robotic actions and natural language instructions, for example. And then a big area that I work in is natural language processing for social science. So, for example, we'd like to measure opinions in society, or measure choices that people make in communication, like how they frame a social issue, or how they pander to different constituencies when they're running for office. We'd like to measure all of this kind of stuff automatically, but it's quite challenging to operationalize social science concepts in ways that are measurable in real text. So that work tends to involve collaboration with people in the social sciences. There are a whole bunch of advanced topics continuing on the analysis line, like natural language inference. Here are two sentences. How do their meanings relate to each other? Discourse processing. So you can think about building parse trees where sentences are the nodes, and the relationships between them are encoded in the tree. Pragmatics is another area that's still fairly theoretical, but people think is really intriguing. What's the actual meaning, the practical meaning of an utterance beyond its literal meaning? There's a whole lot more to be said about how we use machine learning and natural language processing. So I would normally like to teach you a little bit about graphical models and structured prediction, going beyond the dynamic programming techniques we saw in this class. There's a whole lot more. I used to teach a whole semester advanced course on this topic. And then, of course, we could have said a lot more about neural nets. I gave you the basics, but there are many techniques and modules that are now being widely adopted, like transformers you'll hear about. Another one not on this list, we could have spent a lot of time on natural language generation, which is becoming increasingly popular, and a very creative area of research where we want to constrain what the machine says to conform to some expectations. But other than that, we really want to generate language in a naturalistic way. Recently, there was an advanced graduate course taught here by a former student of mine, Walid Amar. His webpage for that course last year is still live, and it has a great reading list of important papers from not just the past couple years, but going back a bit. I recommend that if you like reading papers. If you don't want to read papers and you just want to kind of keep up with what's going on in NLP, Walid and a researcher named Matt Gardner, both at the Allen Institute, run a podcast called NLP Highlights. The URL's on the slide. Check that out, and you can hear about current papers. Often they interview people who have done the work and get them to talk about their research. In this class, there were a few recurring themes that I think it's useful to help organize your thinking as you prepare for the final exam. One big one, of course, is the role of machine learning, and you saw an evolution of a series of different techniques. We don't know what will come next. We don't know if neural nets are going to be the last in this sequence, or if there's going to be a return to something else. I don't like to make predictions about the future, especially when I'm recording myself, but my guess is that the story is not over, and we're going to continue to see new techniques and new advances in machine learning inspired by the problems in NLP. You saw how important data is. You saw how important annotation can be for moving forward on NLP problems. You saw how BiText really shaped the way machine translation developed. We've talked about how this class isn't really just a machine learning class. There are a lot of challenges that are very specific to natural language. The challenge of ambiguity, the fact that the representation we think we want to map into, we don't really know exactly what it is. We have some theoretical ideas, but this thing I called in the first lecture script R, it's really an unknown. It's invisible. And so that makes it really challenging to think about how to go about solving the problem. And of course, language is tremendously varied. You know that any NLP system trained on one kind of linguistic data is unlikely to perform well on data that looks different. So don't take your Penn Treebank parser and expect it to do a really good job of parsing tweets, because the language is just drastically different. We talked a lot about evaluation. Wherever I could, I would introduce a new problem by talking about how it's evaluated, and pros and cons and challenges. And this is always an area where we can get better. And then, we saw, I guess my way of teaching NLP, as I told you at the very beginning, is to try and give you the building blocks, talk about the problems and the challenges, but also give you some of the tools. And some of those were high-level abstractions like noisy channel models, and some of them were much more low-level like recurrent neural nets and dynamic programming. But these tools hopefully will, if you ever see an NLP problem, hopefully they'll give you a starting point. Again, as I said a couple minutes ago, there really are a lot more that I would have liked to have taught you. But once you get the basics, the others become a lot easier to learn, and you can kind of see how they build on each other, and a lot of these ideas are really deeply connected. I want to close by returning to this slide from the very beginning. There are a number of things we care about when we build NLP systems. And hopefully in this class, you've seen examples of some of the challenges of getting at all of these things at the same time in a single system. I think NLP is being held to a very high standard. If you read the press about how we want artificial intelligence to be explainable to humans and very reliable and unbiased, getting all of these things and also understanding how our systems work and making them efficient and making them useful for all the range of human linguistic phenomena is extremely difficult. So my hope is that some of you will continue taking classes in NLP and learning more, and maybe go on to study it or become engineers who are practitioners and continue to advance what this field can do for everybody. So with that, I will close. Wish you all the best of luck on the exam and everything that comes in your future. Thanks for a great quarter.